Hi guys, this is Shahab and this is the second episode of the Roslyn series, and in this episode we want to get familiar with the syntax tree and the APIs provided by the Roslyn and the classes in the C# to create a syntax tree using code. So let's jump into the code. So in this episode we want to use the Roslyn API to create a syntax tree. In the previous episode we saw that one way is to use the syntax factory parse syntax tree, but now we want to take a different approach because this one was accepting a source code which was like a text. And it could happen that there are scenarios that we don't have this text and we want to use the Roslyn API to generate a syntax tree equivalent to a code that we expect to exist. So I created another console application here, and as usual, we make sure that you always added the reference to Microsoft.code analysis.c# NuGet package. Let's copy this code and get familiar with some tools that could help us to generate a syntax tree that represents this code. In this code, we have just a static class, and then we have a static method that reverses a string that is passed to it, and it uses the system.link namespace, and we want to use that. So here we are in sharplab.io. This is a tool I think every C# developer should be familiar with, and it helps us to analyze our C# codes, whether we want a syntax tree of that one or the IL and different things also are here, or even explaining what do we have in here, for example, what is a reference struct and things like that. So today we are interested in syntax tree. And here you will see that our C# file is translated into a syntax tree, and the root node of this tree is a compilation unit. The compilation unit is kind of a representative of a C# file, and when I'm hovering over that, you will see that the whole file is highlighted. If I, for example, hover over the class declaration, you will see that just the part regarding that node is highlighted on the left side, right? The importance of the compilation unit as a root is that, first of all, it provides us with a consistent structure and also a single entry point that guarantees we can traverse all constructs in the file. The syntax tree also consists of various types of nodes. For example, we have syntax nodes. They are abstract classes, the blue ones, that could contain other nodes. Here, a compilation unit contains a file name, file scoped namespace declaration, and this one contains a qualified name using directives, class declaration, semicolon token, and namespace keyword. The second part is the syntax token. They are structs and they are usually the termination in the tree and contains of keywords, name keywords, identifiers, braces, etc. And the last one is, which is also a struct, is the trivias. Trivias do not contribute anything to the semantic of our program or an application, but they are helping with the formatting and the layout of the application. We could also have comments. The comments are also considered as trivia. I don't know, this is a comment. And you will see here I have this one, this trivia as a leading trivia for my public keyword, right? And the trivias could be leading trivia and trailing trivia, which comes after the syntax token. The importance is that sometimes when we want to do code refactoring, it is important to know what kind of trivia is attached to this node that we want to refactor. So in the refactoring, we could also move that comment, or I don't know, these kind of things with the node to some other places. So this is one of the tools we need to know. So now let's go back to our code editor and try to using the Roslyn APIs and C# classes provided for us to generate the syntax tree that we have on the right side and see how it works. Just remember the C# classes representing these nodes comes with a pattern. For example, the C# class representing class declaration would be class declaration syntax, and the one for a compilation unit would be compilation unit syntax. Again, file scoped namespace declaration syntax. Here we are in the code, and as you remember from the syntax tree, the first node in the syntax tree was a compilation unit. So first we need to create a compilation unit for that, and we could use the syntax factory class to achieve that. So here is my compilation unit, right? And then the compilation unit came with some members. Those members dot with members. And here it expects us a syntax list of the members that should be inside this compilation unit or C# file. And I'm going to create a singleton list, syntax factory dot singleton list. And it expects a node to be added in here. And the first, if I'll go back to the syntax tree, you will see the first element is the file scope namespace declaration. So I'm going to create a file scope namespace declaration using the syntax factory. I'm just gonna import a static the syntax factory because I don't want to write it all the time, and it also kills the readability a little bit, to my opinion. So let's go with file scope namespace declaration. And the file scope namespace declaration expect a couple of parameters in here, and we could pass different things. So I'm going to pass first a qualified name, right? And the name was and the qualified name here, if we go to the tree, the qualified name expects two identifier names because the namespace here, because the namespace that we are having in here, it consists of two parts, right? Separating with dots. So we need two different identifier names in here. Let's go back to code. So to this one, we are going to pass an identifier name, and this would be creating syntax trees, and the next identifier name would be extensions. So now we have to add the using statements to our names, to our file scope namespace. And the first thing is that this one also expects a list, so a list of using. So I'm gonna create a list in here as well. And then I'm going to create a using directive. The first thing, this kind of factory methods are returning, the return value is a using directive syntax. So I'm going to use the using directive. And within the using directive, we again need a qualifier. And here we will have like a qualified name, expecting again two identifiers, identifier name. The first one is system, and the second one is link. You see that these classes are helping us with whether they need a parameter as in the constructor or not, helping us to have a almost valid C# code generated. And but the drawback is that it's a cumbersome to write all of those things by ourselves, right? So here comes the second tool that we could leverage in such scenarios to help us generating these kind of codes for us. So here is the second tool that I think it is important when you're working with Roslyn APIs to know about it. And it is the Roslyn quoter, and it helps us to generate a C# code that C# code will generate us a syntax tree equivalent to it. So let's copy paste our code in here. This is the code that we wanted to have its syntax tree. And then if I click on this get Roslyn API calls to generate this code, and let me just zoom a little bit in here. If I click on that, then it will generate us this compilation unit. And I'm just gonna copy that, going to our code here, and replace it here with our code. Importing all the namespaces that is required. The normalized white space in here is just going to do some formatting for us. We could also pass parameters to it. like what would be the end of line, or how much indentation we expect, and things like that. I'm just leaving it as it is. From now on, it would be the same approach as we had at the previous episode. So just the way that we are generating the syntax tree has changed, and the rest would be the same. So here the syntax tree would be C# syntax that create from our compilation unit. And then the next step is to, and actually this is a good suggestion from the my AI tool, console.writeLine. The syntax tree, right? Let's just run the application here, .NET run. And you see, we could just pass the root of the syntax tree, which is our compilation unit, right? And it is showing us the code that is generated for us in here. So this is the code that we actually expected, right? And so let's go now and compile this application, invoke the method, and see whether it works or not. So the next step, as you could remember, was to compile the application. So compilation, and to that you remember we are giving an assembly name, some kind of options, and syntax tree. And remember, we had errors when we were not passing the right references to our application. The first thing we need is from the object class to have all the base types. It is, I think, system.private_lib.core. The second one is the enumerable, because in our code, if I go here to this one that we are using system.link for this reverse method, and in our application we need to pass that. And the last one is the runtime one, which I think this one is not working, but let's just try it. When we have our compilation, then the next phase would be to create a stream, and then we are emitting the results. And if the result is successful, we want to first load the assembly in here. And we want to load the assembly, and then we get the type from that, then the method, and then we want to invoke the method with parameters. And after that, let's just do a write line, reverse the string, and with some colors in there, making sure it is not null, and we should be fine. I'm not just writing for at the moment the else part. Let's just execute the application. Clear .NET run. Okay, we didn't get anything back. It could be we have some errors. Let's print the diagnostics as well. Let's run the app again. Oh yeah, okay. enumerable is defined in an assembly. It's not reference. You must add a reference to assembly system.runtime. Okay, I think this is this one as mentioned. It will not work. So let's have the runtime assembly. And I'm usually using app domain. The current domain dot assembly system.runtime, and then here instead of this, we could say runtime assembly.location. Let's try it again. .NET run. And here we are. It worked. Today we use the Roslyn APIs and provided classes to create a compilation unit, which is representing a C# file. And then from that compilation unit, we are creating our syntax tree. And the rest is the same as previous section. I hope you enjoyed this session, and devam et